Welcome to Creating Your Genius.
Artlist.io.
Welcome back to another episode of Creating Your Genius. I want to apologize in advance for my voice. I'm a little stuffy, fighting off a cold, but we still get out the content. That is the most important thing. Today's episode has been a ton of fun to prepare for and research about. And the topics I'm going to cover today are how our stress response, and hormones like cortisol and oxytocin affect how our brain and body function, and then go into a little bit about what we can do to help modulate our stress response. The inner workings of the human mind have always been pretty fascinating to us. Throughout history, there have been philosophers, emperors, scientists, writers, historians, and many others who have tried to untangle the mess that can be our thoughts. In our world today, it's become even more of a talking point. There are millions of self-help books and podcasts, and they give all sorts of takes on what's really going on in our minds. To be totally honest with you, I have consumed quite a bit of these, and each time they're fascinating. And this does sound like it's going to end up being a criticism of the self-help genre, but that's not really what I'm going for. My aim is to dig into the science and figure out what happens to our body when we get stressed. What impact do our thoughts really have on our biology? We know that our thoughts and emotionally charged experiences affect us in our lives. We also know that our genetics and the environment can play a role in how we behave. There's a really interesting paper called "The Maternal Care During Infancy Regulates the Development of Neural Systems Mediating the Expression of Fearfulness in Rats." This study illustrates how the frequency of licking and grooming and arched back nursing in rats, which are characteristics of maternal care, how those things affected multiple hormone receptors in the brain, and it affected how the rats behaved. To test the levels of anxiety, the rat pups were put in an open field and they were allowed to run free, and how they explored was measured. In this same open environment, they were also given food, and the time it took for them to notice that the food was there and then start feeding, as well as how long they fed, were also measured. So for the rats that received more care, they explored more, they had less time from seeing food to starting to feed, and they fed longer in this new environment. The researchers interpreted these findings as the rats having less anxiety, being more explorative. And for the rats who received less care, they explored less. They took more time to start eating, and they fed for a shorter duration. This was interpreted as the rats having more anxiety. And this makes sense because if you're thinking about being in a new environment and the fact that there could be potential threats in this environment, if you're more anxious, you're more alert, you're more attuned to these threats that could potentially be there, you're not really going to care as much about food. You're going to be more focused on where you operate in space and protecting the space that's around you. So you're not going to be as explorative. And if you do eat, it's going to be you have a bite or two, and then you're looking around to see what's going on. Just want to make a quick note here. These rats were not forced into having care or not. The study just took groups of mothers and their pups, and they looked at the natural differences in the parenting tendencies of these rats and compared them. Going a little deeper in what's happening neurologically with these rats, this study also looked at different chemicals and the receptors that these chemicals have in the brain. This one's pretty fascinating. The benzodiazepine receptor density was higher in the rats who received more care. We all know benzodiazepine is an anti-anxiety compound, and we also know that mammalian species actually produce their own benzodiazepine. So if the rats who received more care had more dense receptors, the genes that coded for that receptor would have to be upregulated, and that's likely due to these rats creating more benzodiazepine while they're in the care of their mothers. The benzodiazepine is the signal that creates the hormonal cascade that turns on the gene coding for the receptor, and there's more input, meaning more gene activation and a more dense receptor. Another fascinating compound and receptor that was upregulated in the rats who received more care was CBZ, and I might butcher this pronunciation, but it's carbamazepine. This compound is known to have anticonvulsant effects as well as anti-anxiety effects. The role in this study for CBZ was how it blocks a receptor called alpha-1. When alpha-1 is activated by adenosine, it stops the cell from producing cyclic AMP. Cyclic AMP is what we call a secondary messenger, and it's a compound that is vital for communicating signals throughout the cell. We could call it even the master communicator within the cell. So when A1 is activated, our cells can actually become incoherent because there is less communication between the organelles, because there's less cyclic AMP that the cells can use for communication. When CBZ is activated, it disrupts the alpha-1, and that disruption restores the communication, because when alpha-1 expression is decreased, it leads to a rush of cyclic AMP being created for the cells. Okay. After that, I know it's tempting to blame our parents for all of our problems, but I really like that study because it illustrates that the environment, in the form of the care that the rats were given by their mothers, stimulated genes in ways that produce different outcomes. And if the environment has an effect on the way the genes are being expressed, we can absolutely use that to our advantage to stimulate the genes that we want. And we could even make some more benzodiazepine. I can tell you from experience that there are some meditations that you can do specifically that are geared towards increasing our own internal production of benzodiazepine. And when I've done them, I can definitely say that I chilled out a little bit. I want to talk about stress and how it impacts the body. Another hot button hormone these days is cortisol. I hear so much about living a lifestyle that reduces cortisol. I've seen cortisol reducing diets. Even though cortisol gets a bad rep, it still has a lot of benefits. It helps us shift into high gear when things get tense. If you're an athlete, I can tell you with 100% certainty that you're not going to be winning anything without cortisol. Cortisol plays an important role in our circadian rhythm. It's very important for helping wake us up in the morning. People who have lower cortisol in the morning, waking up might be pretty tough. Cortisol is a hormone that's made in the adrenal gland, and the adrenal gland is a little gland that sits right on top of our kidneys. And going back to how important healthy fats are in the diet, the molecular building block where cortisol synthesis starts is cholesterol. Cholesterol is turned into pregnenolone, and this is the rate-limiting step of cortisol synthesis, and downstream it eventually gets turned into cortisol. Cortisol is also very important for our ability to actually calm down the body's immune response. It inhibits B and T cells, and this is one of the reasons why cortisol-based creams are used for rashes. They're used in this way to calm down rashes because a rash is part of the body's immune response. You get the rash when you're reacting to something, and in a lot of cases, this could be a maladaptive immune response. So you put the cortisol right onto the place where you're having the immune response. The B and T cells are going to be calmed down, and the idea is that the rash would go away. A little bit about cortisol's structure. Cortisol is a steroid hormone, meaning it's a very small molecule, and it is also fat soluble. This is really important for its function because the fact that it's Fat soluble means that it can pass through cell membranes. So it can go from the external cellular environment into the cell without binding to a receptor. And then when it gets in the cell, it can go from the cytosol into the nucleus and bind sort of directly to DNA and activate genes. This is part of why steroid hormones are so powerful, because they're a pretty rare compound that can directly activate gene expression. Going back to cortisol's importance for our sleep and wake cycle, they have a really interesting pattern. So the normal pattern for cortisol is really important when looking at stress responses and how they impact us. A normal cortisol pattern would look like this. You're going to have your highest levels of cortisol during the day in the morning, right as you wake up, and right when you're exposed to light. This study called Light Affects Morning Salivary Cortisol in Humans illustrates this really nicely. This study took two groups, exposed one to light right after waking up for an hour, and the other group was kept in the darkness for 1 hour after waking. In the light-exposed group, the cortisol levels were significantly higher. As the day goes on, the cortisol level, ideally, is going to decrease, and it's going to hit its lowest point at night. It's thought that melatonin, which is a hormone that helps you sleep, and cortisol work in a way in opposition. And melatonin was shown to suppress cortisol levels in this study called Effects of Melatonin on Salivary Levels of Cortisol and Sleep Quality of Hemodialysis Patients, a randomized clinical trial. Again, this is a very specific subset of patients, but it is more, I mention it more looking at the mechanism and how it seems that melatonin and cortisol, or melatonin has a balancing effect on cortisol. Beyond when we're just waking up and the balance of cortisol that we have during the day, when we get stressed, cortisol rises, and because of cortisol's structure and function, it can be detected in blood, saliva, and tissue. This is really great because it makes it very easy to measure. A study called Effect of Increase in Cortisol Level Due to Stress in Healthy Young Individuals on Dynamic and Static Balance Scores actually gives really great insight into how cortisol levels change when we get stressed and what can happen to our body when cortisol levels rise. In this study, 107 medical students were measured for cortisol levels and had their balance tested in two separate occasions. So they had the cortisol levels tested and their balance tested 40 days prior to an exam, and they had those same metrics tested the day of the exam. On the day of the exam, the average cortisol level spiked over 9 times higher than what it was during the unstressed period. And that unstressed period being the first time that they were measured 40 days before the exam. It'd be really interesting to see how the cortisol levels changed as they got closer to the test, meaning like, what would it be 20 days out, 10 days out, 5 days out? Was there a gradual slow burn increase, or was it kind of stable, and then it just spiked when the acute stress hit? That would be a really interesting question. Unfortunately, the study didn't look into that. For the balance tests, there were 8 different balance tests that the participants performed, and so it was 4 for each leg. And the average score on all 8 tests decreased by an average of 21% on the right foot and 26% on the left foot. I said that wrong. There were 8 different balance tests for each foot, so 16 total. And the study describes balance as balance control is a motor skill that includes planning and practicing flexible movements as well as integrating sensory inputs. The integration of the information coming from perceptive systems gives information to a person about orientation to maintain posture control in a space that allows regulatory reflexive movements. This is a really interesting quote because it gives a better idea of all of the different things that go into balance. You're not just focusing on the way your ankle's moving, your because your eyes are open, so you're taking in information from your eyes. Your body is feeling those little movements of your toes, your feet, your ankles, or even into the bigger muscles in your legs. You're feeling how your trunk is situated. There's so much information that's going on in your body during a balance exercise. And so in this study, when the cortisol levels spiked, the balance, it decreased. They were not able to perform as well. And that illustrates that when the cortisol levels were higher, the body was less capable of managing all of those sensory inputs that were coming in externally. And at the same time, the body was less capable of performing the correct micro movements necessary to maintain balance. In short, I think we could say that cognition, because the brain is controlling basically all of this, decreased significantly when cortisol spiked. I had a few thoughts when reading this study. First, it becomes so much more impressive that the highest level athletes can perform at the way they do under such immense stress. During competition, their body is being flooded with a hormone, cortisol, that disrupts coherent cognition and at the same time makes it harder for their body to perform micro movements and keep balance. It would be really interesting to test cortisol levels during competition and figure out if there's kind of a sweet spot of cortisol production that correlates to optimal performance. And at what point does performance start to fall off a cliff? So my sport growing up was tennis, and this explains to me why when you watch these guys, the pros, when you watch them practice, it's the most unbelievable thing you will ever see. They're so fluid, they're so smooth, and it looks like they're hitting the ball actually harder than they do in matches. And I think that part of the reason why they look better is because they're not under as much stress. Cortisol is not as high. Obviously, there's going to be an increase because they're exercising and exerting, but it doesn't get to that level where performance starts to fall. And you've got to wonder that those who perform the best, are they able to have their cortisol levels get to the optimal spot for performance and hold off the increase to a point where it becomes suboptimal better than those who aren't able to perform as well. Again, that's more just a thought exercise, more so than being able to take away anything solid from it. The second thought, which is much more applicable to our lives, is, okay, cortisol definitely spikes, and cortisol definitely seems to impact our cognition. The example that this study uses is balance, but that's not to say that how we think and how we feel isn't going to be impacted by cortisol. And so if our thoughts are putting us into high stress situations at all time during the day, either because we can't control them or we give them the power to upset us, the increase in cortisol from that would seriously impair our ability to regulate our lives. There's been a lot of research on cortisol's impact on brain health, and going back to 1968, cortisol was shown in a study to damage the brains of pigs, and specifically the hippocampus of pigs was found to be the region of the brain that had the most damage to cortisol, the most damage from exposure to cortisol. And this makes sense. The hippocampus is the region of the brain that has the most amount of glucocorticoid receptors, which are cortisol receptors. And because it has the most receptors, it's going to be the most sensitive to cortisol. The hippocampus is involved in memory, learning, and emotion. And so if that area of the brain is being damaged by a ton of cortisol, that's going to seriously impair us. And this makes sense if we're thinking about our stress response. When we're being chased by a lion, or when there's a drop in blood sugar, or when there's some sort of threat that requires our body to go into a fight or flight state, we don't really need to be learning. We don't really need to be remembering much outside of, if we're looking for food, where are the spots that have the most food? And the emotions, you don't need them as much in these situations. Having an emotional response to the lion chasing you evolutionarily is probably going to hurt your chances of survival more than helping them. So if this is being damaged by cortisol when we're in stressful situations, it's definitely going to impair how we function, especially in today's world, because it's not situations like we're getting chased after by a predator. It's you have a stressful day at work, your boss is yelling at you, you have an exam, you're in school, and somehow we're expected to be functioning at full capacity during all these stressful events. This paper, called Serum Cortisol is Negatively Related to Hippocampal Volume, Brain Structure, and Memory Performance in Healthy Aging and Alzheimer's Disease, discusses how elevated cortisol is a common situation in Alzheimer's disease, and also mentions a phenomenon called the glucocorticoid cascade hypothesis, where high cortisol levels impair the hippocampus, and that dysregulation causes stress on the body, and this stress on the body actually causes more cortisol to be released from the adrenals, leading to even more hippocampus dysfunction. The paper mentions how cortisol levels are elevated all over the bodies of Alzheimer's disease patients, which they've been able to show through testing because, again, like I mentioned earlier, cortisol is so easy to measure in the body. It can be found in the blood. It can be found in your tissues. It can even be found in your cerebral spinal fluid, which is a very important liquid in the body that has to do with how our nervous system functions. This study illustrated that the left hippocampal volume was negatively correlated with cortisol levels, meaning higher cortisol led to decreased volume, and this was more significant in Alzheimer's disease patients. So this is not to say that we're all going to get Alzheimer's because our cortisol levels are high based on the world that we're living, but more to illustrate that cortisol clearly has an impact on how our brain functions. Because there's so much density of glucocorticoid receptors in the hippocampus, if we're working with high cortisol all the time, the expression of those receptors in the hippocampus is going to be upregulated. The interplay between stress, cortisol, and these glucocorticoid receptors in our hippocampus gives really good insight into how we can biochemically get stuck in specific ways of being. And these ways of being would be activating the fight or flight response too much and living in patterns of survival and anxiety and really just looking for threats in our external environment because our internal environment is telling us there is a threat going on. Going back to the rats, whose benzodiazepine receptors and CBZ receptors were more dense, that's likely because they were exposed to more benzodiazepine and more CBZ. And those receptors, based on their higher density in the rats that received more care, are probably going to be more active, and they're going to respond more efficiently to less amounts of benzodiazepine than a less dense receptor would. Based on this, those rats are probably better at being relaxed. It's almost like a skill because of the way their brains developed. They could be needing less benzodiazepine to have the positive impacts of it because the receptors are better at picking it up, or because there are more receptors, so it's more likely that the benzodiazepine that's created finds a receptor. So let's apply that to the cortisol conundrum. The more cortisol we produce, the better our brain is going to get at sensing it. The receptors in the hippocampus are going to get more dense. There's going to be more gene activation to create these receptors. And you're going to have a brain that's basically looking for a cortisol response. Just like those rats had brains that were almost looking for ways to chill out because their brains were like, well, we've got all these benzodiazepine and CBZ receptors. We got to keep them active. So even small amounts would have more of an effect. Again, this is a little bit of just conjecture and me looking at what's going on and analyzing it in sort of what I think is going on, rather than, I don't know the exact mechanism of how this works. But if we're applying how those rats' brains work to how our brains might be working in this crazy world of stimulation, stressful jobs, terrible quality light being blasted at us all day long, and how many things in our environment are cortisol stimulating things, wouldn't it make sense that our brains have been wired to be hyper cortisol aware? I sort of think it does. And it's likely that we've actually become addicted to the rush of cortisol. And that's because those cortisol receptors, they become really powerful. And they don't need as much of the actual stimulus to get activated. And this creates a scenario where your body's just running the show. It doesn't really matter what you're telling yourself. Oh, I need to be less anxious. I need to be more chill. You've got this brain that's hardwired to be like, there's something going wrong in the environment. I gotta be on high alert all the time. Your chemicals are running the show more than you, the mind, are. Dr. Joe Dispenza, who is a chiropractor who's doing amazing research on how the mind and body are connected, and how meditation can influence our genes, and actually how we can influence our genes through meditation, and how we can affect the health of our body solely with our mind. He often says not to let your body be your mind. He says this in lectures, in meditations. And I think this cortisol response and its effect on the hippocampus gives insight into the biochemical mechanisms behind that statement. And I think it also offers a lot of hope, because if we can stimulate our brains to become more attuned to cortisol through all the environmental inputs and through our thoughts, we can also make them more attuned to other hormones that are beneficial. And we could do this based on how we think, how we act, and the environment we surround ourselves with. How we eat, the supplements that we have. Just like those rats' brains, they received more care and their brains changed because of it. Why couldn't we change the inputs and change the brain? This all goes back to the concept of neuroplasticity and how the brain is this constantly evolving structure in our body. It's not just that we have our brain and this is the brain that when you're 25 or whatever age the brain finishes developing, that's the brain you're stuck with. Neuroplasticity says we can always change our brain, and it's all based on epigenetics and environment. That's how we do it. That's how we send different inputs. Pivoting a little bit here, when we get stressed, cortisol goes up. We've gone over that a few times. And when cortisol goes up, this lowers our cognitive capacity and is going to lower our immune system based on it inhibiting B and T cell formation. What other effects does cortisol have on the body? Why is it important from an evolutionary perspective? All of these hormones and all of these things that have gotten out of whack in our weird world today had really specific roles in evolution that were vastly important for our survival. Otherwise, we wouldn't have evolved to produce cortisol in the way we do. Going back through this evolutionary perspective and looking at what are some of the most dangerous things that can happen. One of those is having low blood sugar for long periods of time is very dangerous. It's actually much more dangerous than having high blood sugar. This relationship between survival and blood sugar is one of the most important stressors that our body had to contend with. When blood sugar tanks, the body senses that as a stressor and cortisol release. Cortisol's effect varies in different organs, which is really interesting. But it makes sense because the liver is where we take things like fats or proteins and turn them into new sugars. And this process is called gluconeogenesis. When cortisol rises, its activity on the liver is to tell the liver, hey, we need to make new sugars so that they can be released into the bloodstream so that we can survive and we can raise the blood sugar levels. In the muscles, cortisol inhibits the muscle's ability to oxidize glucose for energy, but it promotes the breakdown of proteins into amino acids so that they can be used to make new sugars. So essentially, the muscles are being told, hey, we need to preserve the sugars that we have, but the proteins aren't as important for our survival right now. So let's take those, get those to the liver, break them down into amino acids, and so we can make new sugars out of them. And in fat cells, the effect of cortisol is different as well. It also decreases the burning of glucose for fuel, but it stimulates the breakdown of fats into materials that can be used to make sugar. If we think about this in the context of low blood sugar, it makes total sense. Before food was so abundant, having low blood sugar was deadly. You couldn't just walk to your fridge and grab a piece of fruit. So when your blood sugar tanks, it's going to be the absolute top priority of your body to fix that issue. If your blood sugar is low, there's no need for your brains or muscles to be working at full capacity. Your body's not going to be focused on building muscle. You're not going to be focused on learning new things. You're going to be like, I need to not die right now. So cortisol is going to strip the materials that make up the brain and the muscles, and it's going to build new sugars out of them, which are released in the blood. The body goes completely into survival mode. There's no room to think about how to be more compassionate or to think about how a car motor works. There's no room for problem solving. The only priority is to raise those blood sugar levels. So after hearing that, if you're wondering if having chronically high cortisol levels, because of its impact on blood sugar and muscle and the brain, could lead to having high blood sugar, the Cleveland Clinic is going to agree with you. And they're actually going to take it one step further, saying that chronically high cortisol could lead to hyperglycemia and eventually to type 2 diabetes. Am I saying that the stress from our world could eventually give you diabetes? Not exactly. I think there's a long way to go from having high cortisol to diabetes, and I would assume that it takes a very long time to get to that endpoint. But I think it's still important to understand the effects that elevated cortisol could have in the body, and that these effects can, one, they can be pretty serious. Diabetes is definitely a serious condition, and two, that they can compound over time. You have one cortisol release that spikes your blood sugar once, not a big deal. But if you get to a point where you're always stressed and you're always producing cortisol, and this goes on for years, that's a very different situation than just a one-off stressful event. Up to this point, I have definitely hinted that by our thoughts alone, we can raise our cortisol levels, but I haven't explicitly said that. In this part of the episode, I am sort of about to do that. And I'm going to use a study called Cognitive Distortions in relation to plasma cortisol and oxytocin levels in major depressive disorder. This study sort of makes that claim for me. This study looks at differences in belief systems between patients with major depressive disorder and a control, and it also looks at hormone levels like cortisol and oxytocin. In the major depressive disorder patients, their baseline cortisol levels were on average twice as high as the control groups. At the same time, these patients were also found to have more negative beliefs, and they were also found to believe in those negative beliefs twice as strongly as the control group. The point about believing in their negative self-beliefs is very important to me, because I think this is actually a better indicator of what's going on and how our thoughts can impact our cortisol. We're continuously bombarded with thoughts all day, but we don't take every single thought that comes into our head seriously. If we did, we wouldn't be able to function in any meaningful capacity. A study from 2020 illustrates that we have approximately 6,000 thoughts a day. If we listened intently and really analyzed and got into the roots of every single one of those 6,000 thoughts, there wouldn't be time for anything else. We would not be functioning humans. So this idea that in the major depressive disorder patients, they were believing more of their negative thoughts. They were giving more energy to these thoughts. And you have 6,000 thoughts a day. That's a lot of thoughts. And if you have more negative thoughts and are believing them more, it's going to create a more stressful situation in your body. A really good example of how we not only don't listen to all our thoughts, but we sometimes actually push back against them comes from a podcast I was just listening to where this guy, Brian Johnson, he calls himself a rejuvenation athlete. He's trying to age backwards, and his eventual goal is to actually live forever, which I think is very interesting. Not really the point, though. There was a specific part of the interview where he was talking about a time where he dealt with treatment-resistant depression for 10 years. And in describing how he felt, he said that every day his brain would bombard him with the thought, you should kill yourself. And every time that happened, he would basically tell his brain, thank you, brain, for your input, but I'm not going to take your advice. He called this not trusting his brain. And to an extent, I think that's true. I think that it is not entirely true, though. At the core of it, it's more of him actually being aware that not all of the thoughts that he thinks are quote-unquote him. And because not all of the thoughts he thinks come from his soul or come from, he doesn't need to assign meaning or take the advice of every thought that enters his head. He can choose which ones he likes, assign more meaning to those, and when he encounters the thoughts that he doesn't like, he assigns less meaning to those, just like the ones he was getting when he was really depressed. This is much easier said than done, though. And after listening to him on the podcast, his proclivity to open thinking and surrendering what he thought he knew about his brain and his body to the unknown is very impressive. This example ties in really nicely with the study because, again, it seems like the belief in the thoughts is much more powerful than the thoughts themselves. Like I mentioned, the major depressive disorder study also tracked the quantity of negative thoughts between the two groups. In the major depressive disorder group, they had a greater quantity of negative thoughts and they believed them more. And also, they had higher cortisol levels. This doesn't say that your thoughts cause major depressive disorder, but rather that in this condition, there are patterns of thinking and believing that are happening constantly, and while they're happening, cortisol is also consistently elevated, and elevated beyond quote-unquote normal levels. This doesn't mean that the thinking necessarily caused the cortisol increase, and it doesn't mean that the cortisol increase caused the thinking and the believing. It just means that they're correlated. They're happening at the same time, and we can take from that what we want. And to me, I think it does do a good job of explaining that our thoughts can, through some mechanism, increase our cortisol levels and increase our stress. There's another part of this study that I want to talk a little bit about. While cortisol levels were increased, this study also found that oxytocin was decreased in the major depressive disorder group compared to the controls. This finding could mean that oxytocin and cortisol are sort of two sides of the same coin in terms of emotion and disposition. And this shifts the discussion in a completely different way. Instead of looking at cortisol as just something that impacts how you wake up, because if that were the case, then melatonin would have to be the other side of that coin. It really goes to show how many roles cortisol has in the body. And if cortisol is the hormone that induces the stress response and shifts us towards survival, oxytocin, called the love hormone, is a chemical messenger telling our bodies that we are safe enough to feel and express love. I can say pretty confidently that someone running away from a lion or taking a stressful exam isn't intently focused on how much they love their partner, parents, or children. And in a life or death situation, those feelings may negatively impact survival. A really interesting paper called Oxytocin, a mediator of anti-stress, well-being, social interaction, growth, and healing, described oxytocin like this. Oxytocin can induce anti-stress effects such as the reduction of blood pressure and cortisol levels. It increases pain thresholds, exerts an anxiolytic-like effect, and stimulates various types of positive social interaction. In addition, it promotes growth and healing. Based on this statement, it would make sense that in conditions like major depressive disorder where cortisol is chronically high, oxytocin would also be low, because oxytocin has been shown to help suppress cortisol. It also introduces a mechanism where oxytocin and cortisol exist in a balance and that they modulate each other. Oxytocin is also very important for pain regulation, and it was actually first discovered in the context of women in labor, because it's a hormone that helps women deal with the pain of giving birth, and at the same time, maybe through the pain, not entirely sure about the mechanism there, it also helps the mother bond to the child. Another study that I want to take a look at is called Marital Behavior, Oxytocin, Vasopressin, and Wound Healing. This study gives fascinating insight into the roles that behavior has on oxytocin, as well as a correlation between oxytocin and wound healing. This goes back to the statement that the other paper presented. This study is really interesting. So couples were brought to a hospital for 24 hours, and they were given small blister wounds. That definitely sounds pretty ridiculous. Anyways, their levels of oxytocin and vasopressin were measured through blood. So after receiving the wounds, the couples were taken through a social support exercise, and their wounds and hormone levels were assessed. The first important finding of the study is that higher oxytocin and vasopressin levels were associated with more positive communication behaviors during the exercise. So clearly, our biochemistry does have something to do with how we interact with each other. And if you have a higher level of hormones that tell you, hey, we're safe, we can express love, we're probably going to express more love. The second interesting finding is that the people who are in the highest 25% of oxytocin levels were found to heal their wounds faster than those in the bottom 25% of oxytocin levels. So there is something to having higher oxytocin and healing better. And this could be, the mechanism here could be because oxytocin suppresses cortisol, and cortisol suppresses the immune system. And we know that we need the immune system to be activated to heal correctly from infections and wounds. So the higher levels of oxytocin were associated with both more positive relationships as well as better wound healing. Again, this is correlation, not causation. We don't know if oxytocin was the exact factor causing the differences in outcomes, but they were happening at the same time, which again is important. We actually have a receptor in the body specifically made for oxytocin, and it is called the OXTR, oxytocin receptor, and it's coded for by the OXTR gene. There's a really interesting variant of this gene that causes people to show more empathy. The people with the variated OXTR gene were found to be more empathetic than the non-mutated gene carriers in a specific study, which I don't have the name for, but it will be in the show notes. In this study, people with the variated gene were found to be more empathetic, but they also, interestingly, had a higher level of sympathetic nervous system activation in response to stressful stimuli. The variation in the OXTR gene is extremely common, and there are a multitude of genes for this receptor, meaning there's a lot of room for variation. The variation could explain why us humans react differently in social situations. So this receptor binds to oxytocin, meaning that if the gene is variated, it could impact the way that oxytocin binds to the receptor, either making us more sensitive to it or less sensitive to it. Based on the responses in this study, I would make the case that the OXTR variants would make us less sensitive to oxytocin, meaning we are more prone to stress and high cortisol. The people with the genetic variants showed higher level of sympathetic nervous system arousal, meaning more fight or flight activation, and this likely means higher cortisol levels. And the higher cortisol levels would have been from the exposure to the stimuli. Unfortunately, in this study, the cortisol levels were not measured, which if I were doing it, I would have measured them because I think it really gives more insight into the mechanism of these two hormones and would have also given us better insight into how the OXTR receptor changes based on the variants. Because if the variated people had higher cortisol levels, we could say it's likely that the variated receptors had a decreased affinity for oxytocin. And based on what we know about the duality of cortisol and oxytocin, it would be fascinating to figure out what effects cortisol has on the oxytocin receptor, and conversely, what impact oxytocin has on the glucocorticoid receptors, which are the receptors for cortisol. Oxytocin is a hormone that links us together as humans, and it also connects us with our world. You could try to tell me that petting a dog doesn't release oxytocin, but unfortunately you'd be wrong about that. Among the many benefits that having a pet does for you, Johns Hopkins Medicine mentions specifically that social interaction between people and their dogs increases oxytocin. Consistently, having healthy social connections in our lives has been shown to be healthy for us. Oxytocin is a big reason why that is. When it's released, cortisol is going to go down. We're going to shift out of that fight or flight state. And we're going to feel safe enough to express love and feel love. I'm going to mention some things that we can all do to help regulate our cortisol, but there is absolutely no substitute for having social connection in our lives. So if you hear this and you're wondering if you should call that friend that you haven't talked to in a while, I think you should take it as a sign to call them. And so with that being said, let's get into some other ways that we can help regulate our body's stress response. When thinking about how cortisol and oxytocin affect our lives, it would make sense that we want to have the most adaptive levels of each and maintain a balance in both of those systems. So what can we do to balance these systems? This takes us back to something I talked about a bit earlier in the podcast. And I think that because of cortisol's importance for a healthy circadian rhythm, healthy cortisol is going to start at night. Cortisol is stimulated by light that mimics the sun. So that's blue light, which is the light coming from your phone, TV, LED lights. That's all blue light. And when your eyes are exposed to this types of light at night, it's going to basically tell your biology, hey, we need to be awake right now. So an easy way to lower cortisol is to lessen the inputs of this blue light spectrum at night. The absolute best way to do this would be to put your phone down and stop using all electronics and screens as soon as the sun goes down. And actually, it would be even better than that to turn off all the lights as well. That isn't exactly practical, I understand, and I don't do that either. So as a workaround, the next best way to be to wear some blue light blocking glasses. My favorite is a brand called True Dark, and while they're not very sexy, as my friends who have seen me wear them can definitely attest to, I found that they're the best ones to filter out the blue light at nighttime. When looking into these blue light glasses, you definitely want to get the darkest red ones that you can find, because the darkest red is going to filter out the most blue light. There are some people out there who say that we need to be wearing some sort of blue light blockers anytime that we're looking at a screen. I can't say that I totally disagree, but in the interest of looking at the one thing that you're going to get the most benefit out of, it would be getting a pair of dark red glasses that you wear at night. And since we're on the topic of light, the flip side, you want to get as much of the stimulating lights as you can first thing in the morning. Ideally, sunlight is the best. I mean, looking at your phone, I guess, works too. Not quite as healthy, but my recommendation would be to go out and get some sun as soon as you can in the morning. This goes back to the study I mentioned earlier, which showed that the people who were exposed to darkness for an hour after waking up, their cortisol response was lower than the people who were exposed to light. And I think there's something to the rhythm of the cortisol response throughout the day. I would wonder if it was blunted in the morning, maybe it stays higher throughout the day. Or if it's high at night, maybe it's going to tank in the morning. I haven't seen research on this, unfortunately, so I can't say for sure. But I do think there's something to that natural rhythm of it spiking in the morning, helping wake you up, falls throughout the day, and eventually at night, it's going to be the lowest. So getting light in the morning, much like blocking out specific wavelengths at night, is a great way to fine-tune that cortisol system. We talk a lot about sending the correct signals for your body, and the light is absolutely one of them. Another one that you can use to send a signal to your body to tell you that it's time to sleep and we don't need quite as much cortisol is using melatonin. Melatonin is the hormone that puts us to sleep and has cortisol reducing effects. It can be a great way to regulate your circadian rhythm when the body has been knocked out of balance. I've found really good success using melatonin when I've traveled to places where the time zone drastically changes. So I give melatonin when the sun goes down. This is the input telling my body to lower cortisol because we're trying to get to sleep. And my body responds to the melatonin. And in doing that, I'm helping adjust the circadian rhythm. And another thing for travel is getting sunlight first thing in the morning in whatever place you are. Again, it's giving the signals to tell your body, this is what the rhythm is. This is how we need to adapt. The body is constantly taking these inputs and responding to them. There's no prejudice, there's no emotion in how the body responds to the inputs. Although your emotions might impact how your body does respond to the inputs, without that, your body's just going to integrate the information and does what it needs to do with it. Ideally, we're making our own melatonin at night and getting our cortisol levels down on your own, but if we need some melatonin to make that happen because you're traveling or because you're so stressed and you just need a little extra help, do it. There's no downside. It's more important to get enough melatonin to help you sleep and lower your cortisol so you can sleep than it is to not take any supplements or medications. The next few strategies to help regulate your cortisol and stress is more about building resilience rather than working on our circadian rhythm. Tools like meditation, yoga, and breath work are all fantastic and things that we can use to train our bodies to be more resilient to stress. I don't do a ton of yoga. I do meditate and I do breath work. And those have been sort of foundational for my practice in building more resilience to stress. And I want to give a little personal anecdote here. Like I said, I've had some forms of meditation practice for years, but I really got more into it in June 2023. I used to have a really hard time flying, and this does have to do with meditation, I promise. I had a really hard time flying and a really hard time relaxing on the plane. Whenever there were bumps, I would just get so anxious, and I had a few experiences where it really felt like the plane was going down, and those made flying definitely much more stressful. Anyways, when I first prioritized my meditation practice, whenever I had to fly, all I was trying to do was to try to manifest myself having the smoothest flight possible. And taking that approach, when the bumps inevitably came, I was still a wreck. And as my practice evolved further and further in the following months, I started to let go of the need to have a smooth flight. And whenever the fears came up for me, whether it was in meditation or just going throughout my day, I just thought to myself, I don't need that thought. And then I replaced it with, I love flying. It's a lot of fun. It didn't matter when it came up. And I've been taking that approach to doing it since then. And I was just traveling, and both of the flights that I took were really bumpy. The second one was so bad that the pilot kept the flight attendants in their seats for most of it. They did do the drink service and stuff, but it was a lot longer into the flight than usual. For one brief second during the flight, I felt my palms start to sweat, and I felt the fear come up, and I just said to myself, it's so cool to be like 30,000 feet in the sky, 35,000 feet, whatever. We're just soaring through it. I was like, this is so much fun. And I was imagining how the pilots, with all their training, probably found these little turbulence challenges as fun. And when I shifted that, the stress it slowly melted away. Again, this has been meditating basically every day for like 8 months now, and I can just tell how when I had to travel, it was like each time it got a little bit better through that. And I feel it in my everyday life. Like I've built a ton of resilience to stress. And I want to compare this flying trip to one I took before I started meditating as consistently. In May, I went to Japan, which is a fantastic trip, like trip of a lifetime. But it's an 11-hour flight, and you can guess that I was probably a wreck. And these flights were actually incredibly smooth, especially compared to the ones that I was just on. But I was so worked up about not wanting to fly and like wanting to get there and whatever. I couldn't relax. And I ended up being awake for like 30 hours straight each way. And that made the first day of being in Japan and the first day of being back in the States pretty miserable, to be totally honest with you. Obviously, it ended up being fine, but if I didn't need to take that hit, I would have liked to avoid it for sure. And I give these experiences to show the progress that I've seen just in myself. I can see that I've built more resilience to stress. And I've been meditating to change my mind and change my body. And I think these experiences are evidence of that. For meditation resources, personally, I love Dr. Joe Dispenza's meditations, who I mentioned earlier, because of how intentional they are. There's definitely a component to them about clearing your mind and going into nothing, but it's more about tuning into the feelings of exactly what you want. And the meditations are about doing the work, taking the time for you and changing how your body is responding. You're changing your mind, you're changing your body. I have just found that there's a level of intentionality to the way he structures his meditations that I've resonated with in a much deeper way than any other meditation practice that I ever had in the past. So if that sounds interesting, he has some great books. I'm just going to name 2, Breaking the Habit of Being Yourself and Becoming Supernatural. There are many more, and they're all fascinating. And if you want to try out what a short meditation of his is like, a simple 15-minute meditation he has is called Go Love 20, and you can find that on YouTube. And I'll also link that in the description. For other meditation resources, Headspace is a great one for beginners who just want a taste of what being more present feels like. I know there's a ton of them out there, but I really only want to talk about and recommend ones that I have experience with. For meditation's effect on cortisol levels, I can refer to a study called Effects of Mindfulness Meditation on Serum Cortisol of Medical Students. And this study found that the cortisol levels dropped in a statistically significant way during the meditation. On average, the cortisol levels dropped 80 micromolars per liter. And I think this is really important because it shows that going through a meditation or mindfulness exercise, Headspace has great mindfulness exercises, by the way, can help you lower your stress response in real time. This isn't just about building resilience in the long term. Sitting down and doing something to clear your head absolutely is going to give you benefits right away. The next one that I want to focus on is breath work. Breath work has become another one of these hot topics lately, and rightly so. Breathing, and specifically breathing correctly, are indispensable for life. And without breath, we would all be dead. That is for sure. There are ways to manipulate your breath to help you train your nervous system to become more resilient. Dr. Joe Dispenza has a fantastic method for breathing, and if you enjoy his work and get into it, you'll definitely find it. But I don't feel like I have the authority to really talk about what's going on with that method here. And it's not really beginner friendly either. For beginners, I think the Wim Hof method is a fantastic modality for breathing. His method involves taking approximately 30 breaths in and out of your mouth and then holding your breath as long as possible. During the hold, you actually increase the amount of carbon dioxide in your body, which helps you use oxygen more efficiently. The hold also involves you contracting muscles in your stomach, which makes you more stable. This method of oxygenating your body and then holding your breath, allowing carbon dioxide to build up, is a stressor to the body. By integrating this stressor, you actually upregulate your sympathetic response, but by doing it in a controlled way, you're really training your sympathetic response to be more adaptive. You can think of this as doing almost like sit-ups for your sympathetic nervous system. If you find that interesting, Wim Hof has a great app called the Wim Hof Method that you can use to get a sense of whether or not his breath work works for you. A really fascinating study actually analyzed an 8-week Wim Hof program, and they did it on people who were doing an Antarctic expedition, which is sort of a crazy stressor on the body. And there were only 13 people, 6 participants, and 7 controls. But it was found that the Wim Hof method may positively affect stress symptoms and adaptability of the hormonal system to respond adequately to the circadian rhythm in healthy volunteers who participated in this Antarctic expedition. So in a situation of intense stress, the symptoms associated with the stress were reduced in the people who practiced the Wim Hof method. It's really fascinating, and the adaptability of the hormonal system is also noteworthy, illustrating that when we do things to tone our stress response, it has downstream effects on the circadian rhythm. And I believe that this is because when you're doing these things to tone your stress response, your cortisol is being regulated more effectively. And when you're regulating your cortisol more effectively during the day, I think in turn, this is going to help regulate the circadian rhythm better. The last tool that we can use to help regulate our stress response that I'm going to talk about is yoga. Admittedly, I am not the biggest fan of yoga. I've done some, but it just hasn't resonated with me the same way as meditation and breathwork have. My biases aside, this study found that participants who did yoga were able to lower stress levels as well as decrease inflammation in their bodies. Yoga involves holding poses or moving through poses in a very intentional way and breathing through these poses. You can almost think of yoga as a combination of breathwork, meditation, and movement. And when I describe it that way, that actually makes me want to do it a lot more. When I have done yoga, really breathing into the positions that my body is in helps calm my mind down and connects me more with my body. Really interesting study called Cortisol and the Antidepressant Effects of Yoga found that those who participated in yoga lowered their cortisol levels over a 3-month period, and at the same time that drop in cortisol was related to a decrease in the Hamilton Depression Rating Score, which is basically just a test that the study used to quantify the levels of depression that these participants were dealing with. So with these tools in mind and learning more about the cortisol response in the body, I know this was a pretty hefty episode. But there's a lot that goes into how we deal with stress, and it's absolutely going to be something that I revisit more in later episodes, because it's always evolving, and it's such an important way of how we regulate ourselves and how we show up in the world. And so I hope that this information is valuable and that you're able to take it and keep creating your own genius with it. I will see you next time.